Hi guys, Sinan this side, and in this video we're going to solve this integration problem, that is integral of root tan x dx. So when you first see this question, this might seem a bit overwhelming because it is, and the whole reason for that is this under root sign on tan x, which is quite disturbing. So first of all, we'll remove that by making a substitution that tan x is t square. So let tan x is equal to t square. Fine. So if you differentiate it, we'll get secant square x dx is equal to 2t dt. Fine. So now let's just rearrange the terms to get dx as this, but if you observe, we still have dx in terms of x. So what we'll do is we'll just make this standard substitution, that is secant square x is equal to 1 plus tan square x, right? So we have this. So I'll just substitute this expression right here. So by this we get dx is equal to 2t dt by 1 plus t square squared. Fine, we have this. Now just simplify it a bit to get 2t dt by 1 plus t to the power 4. So dx is this. This is our final expression for dx. So our equation root tan x dx now becomes integral of e times 2t dt by 1 plus t to the power 4. We have now this expression. Okay, fine. Let's just simplify this. We'll get 2t square 1 plus t to the power 4 dt. Now what we'll do is divide numerator and denominator by t square. And why? And for the reason for that is basically by experience, because once you see why we do that, you'll know why we do that. So let's say by experience, and once you see this, you'll know why we did that. So what we'll get is integral of 2 dt by t square plus 1 over t square. Fine. So we are done till here, and this expression is something we can actually deal with quite easily. So again, another manipulation. Write 2 as 1 plus 1. Might seem weird if you are watching this for the very first time, but it actually makes our job easier. So what this will give us as integral of 1 plus 1 dt by t square plus 1 over t square. Fine. And now add a 0 in the numerator. So add a 0 in the numerator. And why do we do that? Again, I'll show you why. So okay, so we get 1 plus 1 dt over t square plus 1 over t square, and that artificial 0 that I was talking about is plus 1 over t square minus 1 over t square. And why exactly we did this, again, you'll see in a few steps. Okay, so we have this term, or rather this term and this term. Let's just separate these integrals into two. So what we'll get is this integral of 1 plus 1 over t square by t square plus 1 over t square dt plus integral of 1 minus 1 over t square dt and t square plus 1 over t square. Fine. Now let us call this as integral 1 and this as integral 2. Let's solve I1. So what is I1? I1 is integral of 1 plus 1 over t square plus 1 over t square dt, right? And again we add an artificial 0 right here by subtracting 2 and then adding 2 like this. So basically this term is 0 and this is done for simple slight manipulation. And if you observe, what is this? This is t plus 1 over t minus 1 over t, whole squared. And this is beautiful. If you see it for the very first time, it's really nice. So 1 plus 1 over t square by t minus 1 by t whole square plus 2 dt. And now if you let u is equal to t minus 1 by t, so you'll get du as 1 plus 1 over t square times dt, and this term is here, right here, and this u is basically this term. So, and when you substitute that, you will get something u square plus 2, and this is a standard integration form, and you can basically integrate this one. So if you remember, it was the standard integration. So the formula goes like this basically: dx over x square plus a square integral is equal to 1 by a tan inverse x over a plus c. Fine. And so basically we now get it as 1 by root 2. So rather than this, let's do one step extra, that is du u square plus root 2 whole square. So we now have a one-to-one correspondence. So by that I mean, in place of x we have u, and in place of a we have root 2. So basically now this becomes integral, oh no more integral, this becomes 1 over root 2 tan inverse u by root 2, and let's say the constant of integration is c1. So c1. Now u was what? U was t minus 1 by t. So 1 over root 2 tan inverse t minus 1 over t by 2 root 2 plus c1, and this gives us 1 over root 2 tan inverse t square minus 1 by root 2 times t plus c1, and again tan x is t square, so 1 over root 2 tan inverse tan x minus 1 and root 2 tan x plus c1. Fine. So this is your answer for I1. So now let us solve for I2. What is I2? So I2 was integral 1 plus or 1 minus 1 over t square dt, and by t square plus 1 over t square. Now again, what I'll do is again add an artificial 0 by plus 2 minus 2. And if you observe, what is this? This is t plus 1 over t whole squared. What this gives us is basically integral of 1 minus 1 by t square over t plus 1 by t whole square minus 2 dt. And if you let s is equal to t plus 1 over t, ds is equal to 1 minus 1 over t square dt, and this is right here in the numerator, and this term, that is the s, is right here. So again, if you just do the substitution, and so you'll get integral of ds over s square minus 2. And now again, this is a standard integration form. So what we'll do is, if you remember, integration of dx x square minus a square is equal to 1 by 2a ln mod of x minus a by x plus a plus c. So what this gives us is basically this integral of ds. I'll just do one more step, which is this s square minus root 2 whole square. So we have a 1-to-1 correspondence. So here x is s and a is again root 2 in this case as well. So what this gives us is equal to 1 by 2 root 2 ln norm of s minus root 2 s plus root 2 plus, let's say the constant of integration is c2. This gives us 1 by 2 root 2 natural log of, so s was what, 1 plus 1 over t, so t plus 1 over t root 2 minus, so and t plus 1 over t plus root 2 plus c2, and this gives us 1 by 2 root 2 ln t square plus 1 minus root 2t t square plus 1 plus root 2t plus c2. So we are almost done, and now as t square is tan x, we get 1 by 2 root 2 ln tan x plus 1 minus root 2t tan x plus 1 plus tan x root 2 tan x plus c2 plus, right, and so this is your final answer for I2. So we are basically done. So integral of root tan x dx is basically I1 plus I2, which is what? This is equal to 1 by root 2 tan inverse tan x minus 1 over root 2 tan x plus c1 plus 1 by 2 root 2 ln tan x plus 1 minus root 2 tan x by tan x plus 1 plus root 2 tan x plus c2. Now just to simplify it even further, what you can do is you can write a plus c and just erase these to integration constant and write where c is equal to c1 plus c2, and we are done. So this is our solution for this integration problem. Hope you enjoyed it, and I will just upload this PDF solution in the description down below if you want to check that out. Please, if you enjoyed the show, hit the subscribe button, share it with your friends, and be sure to hit the thumbs up button. And yeah, if you want any more questions for me to solve, just post them down in the comment section below. Thanks. See you soon. Bye.